This is lesson 7.3, proving that a quadrilateral is a parallelogram. So everything we learned that is true about parallelograms can be used to prove that it is a parallelogram. So first of all, the definition of a parallelogram can be used, right? If we could prove both pairs of opposite sides are parallel, that would make it a parallelogram. But now each of the theorems we learned, the converse would also now make it the parallelogram. So the parallelogram, opposite sides, converse, if I can show it has two pairs of congruent opposite sides, that makes it a parallelogram. All right, parallelogram, opposite angles, converse. If I can show it has two pairs of congruent opposite angles, then it is a parallelogram. This one is not one of the properties that we learned. So this is actually new, and instead of being a converse, it's just a theorem. It's called opposite sides parallel and congruent theorem. If I could show one pair of sides, and it's the same pair of sides, is both congruent and parallel, that makes it a parallelogram. I don't need to know anything about the other two sides as long as these two are both congruent and parallel. And also the parallelogram diagonals converse, if I can show that the diagonals were bisected by each other, that makes it a parallelogram. So some questions we have are basically treating it as if it was. They're asking for what values would it be a parallelogram? Okay, so what would it be if it was a parallelogram? If this was a parallelogram, then the opposite angles would be congruent. Sorry, opposite sides. I could say that 2x minus 1 is equal x plus 9. Subtract that and add the x would have to be 10 for it to be a parallelogram. And I could do the same thing for the sides here. Now that I know x is 10, y equals x plus 7, which means y equals 10 plus 7. So y would have to be 17. All right, you're going to try this one using the opposite angles. Pause when you're ready to answer, hit play. All right, so for opposite angles, they would be congruent. So the 3x minus 32 would be equal to 2x. We're solving it x is 32. The opposite angles 4y equal y plus 87. We're solving, we get minus 20. Some idea for what value of x is CDEF a parallelogram. So these are the diagonals that should be bisecting each other, which means this segment would have to be the same as this segment. So 5x minus 8 would have to equal 3x. Subtract 5x to both sides, we get negative 8 equals negative 2x. Divide by negative 2, and we get x is 4. So you're going to try this one for what value of x is MNPQ a parallelogram. Pause when you're ready to see your answer, hit play. All right, once again, we set our angle, our segments equal. So 2x equals 10 minus 3x. Add 3x to both sides, we get 5x equals 10, and x equals 2. Then we get to some problems. Determine whether each quadrilateral is parallelogram, and if so, state the theorem, and really, or converse. So in this one, I see that these sides are congruent and these sides are congruent. So this is yes. This was the parallelogram, opposite sides, converse, because we are talking about the opposite sides being congruent. This one, these sides are parallel and these sides are parallel. So this is actually yes, but instead of being a zero, it's actually the definition. This is the definition of parallelogram. All right, our next one, these sides are parallel with triangles and they're also congruent. So this is yes. Opposite sides congruent and parallel theorem. And this last one has these sides parallel and these sides congruent, which is different than what we saw in the previous one because it's the same pair of sides that has both markings. These sides have one marking, these others have the other. So this is no, because it's not the same sides. Oh, that's too many E's. Same sides, parallel, and congruent. So if you can't remember the name of the theorem, just tell me exactly what you see happen. Both pairs of opposite sides congruent. Right? Both pairs of opposite sides parallel. right, so go ahead, try this one, or these three. Pause when you're ready to see the answer, hit play. All right, so one was yes, the opposite sides parallel and congruent theorem. Number two was yes, the opposite parallelogram, opposite sides converse. And three was yes, the parallelogram, opposite angles converse. We also could have said yes because one pair is parallel and congruent. Yes, because both pairs of sides are, both pairs of opposite sides are congruent. And yes, because both pairs of opposite angles are congruent. So the last thing we have is we're going to complete this proof. We are given that both of these figures are parallelograms. We want to prove that segment AG is congruent to segment ED. So if we already know that they're parallelograms, we don't have to use converses to make the actual theorem. So AG and BC are congruent because of opposite sides in parallelogram ABCJ. So that's parallelogram, opposite sides. And then ED can convert to BC because they're all part of parallelogram BCD is also parallelogram opposite sides here. And now there's both congruent to BC, so I say A is congruent to ED. If it's told us that always a 30, the transitive property. And this is 7.3, proving quadrilaterals are parallelograms.